Hello student, welcome to the second lecture of video lecture series of analog and digital communication. Today we will discuss about modulation and need of modulation. The outline of today's presentation are what is modulation, the concept of the modulation, need of modulation, and at the end I will share you an interesting video which will explain you the whole process in an interesting manner. Let us move to the first slide, that is what is modulation. Modulation means a change or a variation. In this process of modulation, one signal changes in accordance with the other signal. Here the signal which changes is called as a carrier signal, and the signal which is the mean for change of carrier signal is called as the message signal or modulating signal. By definition, it is the process of changing some characteristics of the carrier signal in accordance with the instantaneous value of the message signal or the modulating signal. So here the carrier signal that has certain parameters, those parameters they changes, and the carrier is get converted into a new signal that is called as modulated signal. In the process of modulation, which will be there in this slide, which is concept of modulation, why modulation is required and what exactly happens in modulation. In modulation process, a message signal is required to transmit to a far point. Actually, the message signals usually in practical case comes under the audio frequency range, that is from 20 Hz to 20 kilohertz, and these signals they are having low frequency and low power. So if we want to transmit those signal alone from one point to a far point, there may be a possibility that they may not reach to the far point. So to make it easier, the signal needed to be transmitted along with another signal, which the second signal is the high frequency, high power signal. The second signal bears high power, so that could able to carry this message signal along with it. So that's why the second signal is called as a carrier signal. As it is written over here, the low frequency, low power message or modulating signal do not have the capability to travel or propagate to a far point. That's why a high frequency, high power carrier signal is needed to carry the message signal. In this process, the carrier signal it changes and we converted into a new signal that is called as the modulated signal. When the carrier signal is get changed, it changed by its characteristics. So some of the characteristics are the phase frequency and amplitude. Next is need of modulation. Why we do need the modulation? What happens if we send the message signal alone? So there are 4 points or the 4 needs for which we do require modulation. The first one is the practicality of antenna. Actually, in modern communication system, signals are transmitted through open space, that means wireless medium or channel, where we do take the help of transmitting and receiving antenna. And the structure of this transmitting and receiving antenna plays a vital role, and this structure depends upon the operating frequency, that means the frequency of the signal to be transmitted. So researchers have said that, or scientists have said that the fundamental length for the transmission of signal of the antenna, that when the fundamental length of the antenna for the transmission of signal becomes lambda by 4, where the lambda is the wavelength of the signal to be transmitted. So as I said that the message signals and modulating signals, they are of a very low frequency, they usually comes under the audio frequency range, whose range is from 20 Hz to 20 kilohertz. So to transmit this low frequency signal, the wavelength required becomes around 15 kilometer if we consider the highest frequency value, that is 20 kilohertz. The range is from 20 Hz to 20 kilohertz. If we take the highest frequency value, that is 20 kilohertz, then we will have the wavelength as 15 kilometer. So that is the lambda, and lambda by 4 becomes 3.75 kilometer. That means the structure or the length of the antenna becomes 3.75 kilometer, which is practically impossible to design, and which is also practically impossible to install the antenna at a very top point. Usually the antennas are installed at the top of the buildings or the top of the towers to take first one is the designing of this kind of antenna is impossible, next to impossible, and to install that at the highest position is also very difficult or next to impossible case. That's why modulation is required where frequency translation occurs from the low to high value. Before modulation, the message has certain frequency that is low of low value, but when it get modulated with the carrier signal, the message signal that attains virtually the frequency of the carrier signal. So frequency translation occurs from low value to high value. So when the for the lower value, the if the length of the antenna is 15 kilometer around, the wavelength becomes 15 kilometer around and the length becomes 3.75 kilometer around. If the frequency is increased from lower value to higher value, the length becomes reduced from 3.75 kilometer to the practicable case or feasible means value or condition. Next need of modulation is the reduction of interference. As I said, in modern communication system, all the signals they are transmitted through space or air or through wireless medium. When these signals they are transmitted through the wireless medium, they are exposed to the other signals. Those are transmitted by other base stations or transmitting stations. So when those signals are get intermixed with each other, or when they come come in contact with each other, there will be a probability of intermixing of that signal, and that is called as interference. Okay. Now what happens? Most of the, as I said, most of the message signals in practical cases they are coming under audio frequency range, that means 20 hertz to 20 kilohertz. So if the multiple signals having same frequency range, they will intermix with each other. In that case, what would happen? The signal which will have lower power value or lower means lower power value, they will get means attenuated by the signals having higher power value. And to avoid that, what happens? We do require to take the help of modulation. In modulation, we take the help of different carrier signal. So when it comes to transmit, means multiple number of signals in space which is open source, we have to transmit those signals in different means through different carrier, with the help of different carrier, which will translate the frequency from lower value to upper value. So when the frequency of the message get increased from translated from lower value to upper value, so the message power will increase. So high power message could not easily get attenuated by any other signals, or they could not easily get interfered with other signals. So that is written over here. Made to propagate through wireless medium. There is a probability of interference of multiple signals. Those are transmitted by different sources. When two signals having same frequency range interfere with each other, then one signal may get attenuated due to other. Which one is get attenuated? The signal which is having low power. During modulation, frequency translation occurs to different high values with the use of different type of carrier signal. The use of different values of carrier signal for individual messages signals refrain them from intermixing. So this is the thing, whole thing happens in modulation, and this is the second point, reduction of interference. The third need of modulation is reduction of noise. As you know, noise is an unwanted signal. Again, when the signal is transmitted through wireless medium, any message signal may encounter any unwanted signal. So when the unwanted signal is get in mixed with the message signal, there will be a probability that during the mixing of the message signal, unwanted signal, the message signal may lose its existence, or may lose its shape and size or structure. Okay, so to avoid that, what would happen? We need to increase the power level of the message signal, and that can be made possible with the help of a carrier signal. With the help of a carrier signal, when carrier signal is get intermixed with the message signal, the message signal virtually attains a high power value. So as it is written over here, when the signals are made to propagate through wireless medium, there is always a probability of intermixing of unwanted signal, that is noise. This mixing of unwanted noise may cause attenuation or loss of the transmitted signal. To avoid this probability, the power level of the transmitted signal must be kept as high as possible, can be achieved by the process of modulation. So this is the third point of need of modulation, that is to reduce the impact of noise. Last but not the least, the last point is the multiplexing. It is a process of transmission of multiple number of signals or message signals simultaneously through a single channel. So when a multiple number of signals are simultaneously transmitted through a single channel, why it is so required? Because in modern communication system, what happened when we convert message signal into a digital form, we'll convert that into 10 of pulses. So between two pulses, there will be a vacant space, and those vacant space can be used during transmission by the other sources or other message signals also. So that's why those vacant space of the channel can be utilized simultaneously by any other source or signal, and that is called as the multiplexing. So when it comes to transmit multiple number of signals simultaneously through a common channel, if the signals they will be there in a common range, that means 20 hertz to 20 kilohertz, there will be a probability of intermixing. And so to avoid this intermixing, these individual message signals they will be transmitted through with different carrier signal. So when they will be individually modulated with different carrier signal, they will attend different envelopes. Okay, so when each signal will attend individual envelope, so when they will transmit simultaneously, there will be no intermixing or interference. So multiplexing could be possible during that period of time. So as it is written over here, it is a phenomenon of transmitting more than one number of signals simultaneously at a time through a single channel or a medium. During simultaneous transmission, if the signals have same frequency range, then they may interfere with each other. To avoid this probability, individual signals will be transmitted with separate carrier signals. If different message signals modulates with different carrier signals, then they will attain different envelopes. After which, if the signals will be transmitted simultaneously, then there will be no interference. So all these 4 points are there, which makes modulation so important. So these need of modulation are there. So let us as I said, I want to show you one video related to the modulation. Let me need of modulation. Thanks.
Name for modulation. At the end of this lesson, you will be able to define modulation, explain the name for modulation. In the previous topic, you were introduced to the communication system. In this topic, you will learn one of the important processes used in communication system. It is modulation, which literally means change. Before heading to the topic, let us look at an analogy to understand the need for modulation. Do you think that you can throw a piece of paper meters? It is impossible because the paper is of less weight. At the same time, if you enclose a stone inside the paper, it can reach longer distance when it is thrown. This is because of the stone's weight. Stone carries the paper along with it. Here, we can compare the less weight paper to the low frequency message signal in the communication system. This weight signal cannot travel across longer distance without any loss. Hence, we will take the help of a high frequency carrier signal. By superimposing the low frequency message signal with the high frequency carrier signal, we can send the message over longer distances. One of the popular communication systems where the process of modulation is applied is in radio communication. Most of us have radio in our house, right? Radio gets the signals from the base station. The frequency of human voice signal ranges from 20 Hz to 20 kHz. These are low frequency signals. It is impossible to transmit these low frequency signals directly due to certain drawbacks. Let us see what are the problems involved in transmitting the low frequency signals directly. The first problem is the height of the antenna. In any communication system, for transmitting a signal, we need an antenna. For efficient transmission, the height of the antenna should be at least one-fourth of the signal wavelength. If we consider sending low frequency of 15 Hz, the wavelength is 20 kilometers. Then one-fourth of the wavelength is 5. Thus, we need to design an antenna with a height of 5 kilometers, which is practically impossible. The second problem is interference. If there is more than one base station in a city, then the signals with same frequency get mixed up with each other. The third problem is poor reception. As per the equation representing the energy of the electromagnetic wave, it is clear that the energy of low frequency signal is very low. On traveling across a longer distance, they become very weak. Another problem is the effective power radiated by an antenna. Theoretically, the power radiated from a linear antenna of length L is proportional to L by lambda whole square. This shows that when we transmit a message signal of longer wavelength, that is, of low frequency, the power radiated will be very small. The reason for all these problems is the low frequency of the signals. If the frequency is high, we can overcome all these problems. But how will we increase the frequency of the message signal? Actually, we will not increase the frequency of the message signal, but we will superimpose the low frequency message signal with the high frequency carrier signal. Hence, the characteristics, that is, amplitude, frequency, and phase of the carrier signal will be changed in accordance with the message signal. This process is called as modulation. Let us see how the problems in the transmission of the low frequency signals are overcome by modulation. To overcome the problem of antenna height, if a high frequency signal of 1 MHz is used, the height of the antenna will be around 75 meters, which can be achieved practically. To overcome interference, if the stations transmit high frequency signals like 2 MHz and 6 MHz, then their difference will be high, that is 4 MHz, and thus the waves will not mix with each other. To overcome the problem of poor reception, if the frequency of the signal is high, automatically the energy of the signal will also be high, and hence we can obtain a good quality signal at the receiving end. By using high frequency transmission, we can achieve high power radiation without changing the antenna height. Modulation helps us to replace the wired medium with wireless medium communication. Also, we can achieve a high range of communication by using modulation. So far, we have studied about modulation and the need for modulation. When the modulated signal reaches the receiver, it is necessary to separate the message signal from the carrier signal. This process of recovering the low frequency message signal from the modulated signal is called as demodulation. Now, let us solve a problem based on height of the antenna. Find out the height of the antenna required to transmit a watt signal of frequency 3 kHz. We know that for efficient transmission, the height of the antenna should be equal to lambda divided by 4. We can obtain the wavelength from the equation shown here. Thus, the wavelength is 100 kilometers. One-fourth of it is 25 kilometers. From this lesson, you have learnt about modulation, problems in direct transmission.
I think this video made you possible to get certain fundamental of modulation and need modulation. So thank you.